Hey guys, Mrs. Traver here. We're going to walk through notes on analyzing graphs of polynomials. We're going to work through 4 examples on this. And the game plan on each of these polynomials is to come up with a table, fill in some points, and then check with our graphing calculator to make sure our graph is as approximate as we can. So I've got myself set up with an XY table here for the first problem. And notice a couple points I added on to my table were negative infinity and positive infinity, which goes to serve that those aren't actual points. I can't actually plug in a coordinate point for negative infinity, but I can think about where my graph would end up as x heads towards negative infinity, thinking about the end behavior of my polynomial. So I do know that this is a positive out front for the leading coefficient and odd. So this is odd is going to tell me it's either going to go up, down, or down, up. So they're not going to match. And it's positive, so it's going to end up positive. So I know right off the bat it's going to end up looking something like this. As the ends. So the ends are telling me that as x heads to the left, this is going to head towards negative infinity. And as x heads to the right towards positive infinity, y is also going to head towards positive infinity. So I know that much. So that'll help me finish my graph. And then let's get some points for these guys. We could go ahead and plug in and solve. So -1 times itself 3 times is -1. 0 times itself 3 times is 0. And 1 times itself 3 times is +1. So we can graph these points. Let's go ahead and graph the ones that we can. -1, -1, 0, 0, and 1, 1. And then I know that it's going to head towards negative and towards positive, but I do want to know that this isn't going to be a perfect line. We know it's got a curve. We know it's got 2 curves. So from here to here, it's going to curve once, and from here to here, it's going to curve a second time. So let's make that happen, so to speak. There we go, something like that. And then I can finish my graph because I know that to the left it's going to keep going down. So I can just keep going down for that and give it kind of the direction it was. And then again, keep heading up on that one. Hold it in a bunch. It's good to check on a graphing calculator. So on our y equals, I've got a few functions in there. But my first one is y equals x cubed. I can go ahead and let's check our table first, our window, I should say. Our window is at -5 to 5 and -5 to 5, so that should be good to graph. And that looks pretty darn close. We're zoomed in a little bit, but overall looks good. Let's do another one. All right, this one I've got f of x equals x to the 4th minus 3x squared plus 4. And there's a lot more going on this one to solve for. Let's first just look at our leading coefficient is positive, and our degree is even. So even degree tells me it's either both up or both down. And since it's positive, I know it's going to be a both up situation. So I know that both of these are going to head towards positive infinity. As for my points, it kind of gets a little annoying to keep plotting a table for this. So let's go ahead and go into our y equals. I'm going to highlight this equation. That's the one I want to be on. X to the 4th minus 3x to the 2nd plus 4. And let's look at our table. So our table here has -1, 2, 0, 4, and 1, 2. So I've got 2, 4, 2 for the spots that I'm going to plug in on mine. So let's plot those points. -1, 2, 0, 4, and 1, 2. All right, and then I also know that both of these are going to head towards positive infinity. So I can kind of connect these ones parabolically. Oops, I was doing this in red, wasn't I? I can connect these ones parabolically, but I know that after I hit these points, each of them are going to end up going up towards positive infinity. So it's going to end up looking kind of like a W, and I just got to curve this guy to make that look like it's really happening. Let's check ours with the graph on here. So we've got that one highlighted on our y equals table. And on the graph, let's check ours with theirs. That looks pretty good. Notice ours, I centered ourselves a little bit on our table, and theirs is centered. So we'll be all right there. Let's look at the next one. All right, there we go. This one, we've got a odd power, so that means that it's either 1 up, 1 down, or 1 down, 1 up. They don't match. It's negative, so it's going to end negative. So it's going to look something like that. So our x's, as they head towards negative infinity, our y's are going to head towards positive infinity. And our x's, as they head towards positive infinity, our y's go down towards negative infinity. It's supposed to be a negative. There we go. As for our points on our table, I've got this guy highlighted, negative x cubed plus 2x squared minus 4. And I can look at the table. For negative 1, I have negative 1. For 0, I have negative 4. And for 1, I have negative 3. So negative 1, negative 4, negative 3. Let's plot those points. Negative 1, negative 1. 0, negative 4. And 1, negative 3. All right, let's see. I'm going to curve once. And this guy is going to end up going up, and this one's going to end up going down. So I can kind of imagine I'm going this way to start. And then I'm going to have to, there's my one curve. There's my second curve, because I've got to head downwards now. So you know the amount of curves based on the degree minus 1. We had degree 3. So I knew I was going to turn directions twice. So here was my first turn of directions, and here's my second one. And now I've got my end behavior that matches. Let's one more time check ours with that of the table graph. Looks good, and I've got myself moved down on my graph a little bit, so I think that matches up pretty well. Last one, it's got a fraction in it, which I know you love to hate, especially with graphing calculator, though. It doesn't make any difference. It's not any harder or easier when there's a fraction, especially because you're just typing it in. So we've got our points here. Let's see, we've got an even power, so either they're both up or both down, and it's negative out front, so this is going to be a both down situation. So I know that both these are going to head towards negative infinity. From there, let's plug in our things to the table. Actually, let me just get these out of here. There we go. So I think that matches up okay. I put 0.5 in instead of a half. But other than that, it matches. Let's look at the table. The table has negative 1, negative a half, 0, 1, and 0, 1 half. So negative 1 half, 0, and 1 half, or 0.5 for both of those. So let's plot those points. I've got negative 1, negative 1 half, 0, 0, and 1, 1 half. So those do make a dead straight line, but I know that this is going to curve 3 times. It's going to end up going down this way and down this way. So let's figure out our curves. There's going to be 1, 2, 3. There's one more up here then. So here's 1. Oops, I'm sorry. Yeah, 1, 2, 3. There we go. So I think we've got ourselves settled. We'll make these be the same height. So they're symmetric. So it kind of looks like an M. I say sketch on these ones because it looks a little messy until I outline it a few times. Let's match this with the graph on our calculator. Notice ours is kind of dipping a little bit more than it should. Let me zoom in a little bit more. Let's go from negative 1 to 1. Actually, let's go from negative 2 to 2. And negative 2 to 2. So I'm zooming in a little bit. Yeah, ours is 2 curves. So it's good to check it on here to know. We should maybe have it be a little bit more flattened out right there. So it's less of a change directions and more of like a dip. So I had a point here and a point right here and here. So it's more of like a dip than a change of directions. So that's what the graphing calculator is there to help us out with, to match those up. So my advice to you is plot some points and make sure you check out your end behavior. Other than that, it is all set. Table to graph. Simple enough. I will see you guys next time.